Are you able to see my PPT?
Yes, sir.
Yes, sir.
So this is the problem we were discussing in last class. Okay, even though this problem looks very simple. Okay, this problem is the simplest of all the problem which we are covering in this transport phenomena. Simplest. But this we will be discussing all minute parts in this problem, and which will be applied to all other problems also. So content wise, this problem is very important. If you understand this problem, you can solve any problem in shell balance. Okay, shell balance for heat transfer, shell balance for mass transfer, and shell balance for momentum transfer. All fundamentals point by point we'll be discussing in this problem. This problem is very simple, easy to understand. Hence, we can understand all the fundamentals behind all this shell balance approach. Okay, so I request everybody to give all attention. And if you have any doubt, any minute doubt also, you can raise the doubt during class also, after class also, or you can just contact me on WhatsApp or anywhere. But you understand this problem in detail. Nothing should be left in this problem, and this is the easiest of all the problem what we are going to cover. Slowly we'll add the complications, complicated points. Okay, not complication, complicated point to be discussed, and slowly we will understand how to solve the complex problem. Okay, so this is the problem. Consider a flow over flat plate of liquid. It is given liquid. Okay, liquid down an inclined plate of length L and width W. So this inclination is beta. Okay, beta with horizontal. So, and this is actually, you can consider, okay, parallel, means in your eye level. Okay, so this is what this is the length of the plate, and width of the plate is perpendicular to the screen, exactly perpendicular to the screen. And there is a flow of this liquid under the influence of gravity, and there is no gravitational direction perpendicular, gradient of gravitational direction perpendicular to this plate actually. So there will not be any flow in other direction, so only flow is in this direction. So inclination angle of the plate is beta, and thickness of the film over this is kept constant. This is kept constant so that delta is kept smaller enough to neglect the acceleration due to gravity, and larger enough to so that it cannot prevent the velocity. If delta is very small, only one layer, then certainly there will not be any flow. Delta is say one layer of molecule here, then there will not be any flow. When I have add a second layer, third layer, and then it will start moving. Actually, it will start moving. So delta is very small as compared to neglect the acceleration, but acceleration is not there. Viscous forces are dominating over a gravitational force. Viscous forces are dominating over gravitational force, and derive the velocity profile, and it is given that viscosity is constant. It means that it is obeying Newton's law of viscosity. Density is constant, so liquids, incompressible fluid. So we can add appropriate assumption. Once we got this velocity profile and momentum flux profile, so you can get all this: maximum velocity, average velocity, mass flow rate, drag force, everything we can get. Only the important is velocity profile and hence momentum profile, actually momentum flux profile, that we'll see. So in last class we had a brief discussion over this problem, and we have seen actually. So this is the problem. This is the problem. So one directional flow. Just now also I mentioned that this is the 1D flow. So flow is there only in one direction. There is a velocity only in one direction, that too under the influence of gravity. This plate is perpendicular to screen. Plate is perpendicular to screen, which is nothing but the W. W and L is length. This is the length. This is the length of the plate, and W is perpendicular to the screen. So, and there is only flow parallel to this length. Flow parallel to this length, and delta is very small as compared to length and W. So film thickness is very small. Okay, this delta is very small as compared to length and W. So that is what it is given, and so this will be the a non-vanishing velocity element. Okay, non-vanishing. So which velocity will be there? This is the only velocity for the flow of the fluid. It will not flow perpendicular to screen. Okay, and it will not flow perpendicular to plate also. Perpendicular to plate is one direction. This L is one direction, and perpendicular to screen is another direction. There is no velocity in any other direction. There is only one velocity in this direction, which is parallel to length. Parallel to length, this is the only one velocity available. This is clear to everybody. There is no velocity perpendicular to whatever screen you are observing. Okay, fluid is not moving perpendicular to screen, that is W direction. This is length direction, and fluid will not move perpendicular to this plate also. In this direction also fluid is not moving. Okay, there is only one velocity element which is parallel to length of the plate in beta direction, in beta angle with a gravity. This flow direction is under the influence of gravity. There is no other force given. Okay, because here potential energy of the liquid is higher as compared to potential energy here. Hence liquid is flowing, and this potential difference in potential energy is merely because of this gravity. Because this is open flow, it is open to atmosphere, this is open to atmosphere, so atmospheric pressure under the influence of atmosphere. So there is no, this is not a closed flow, otherwise pressure will play a role. So this is the under the influence of gravity only. Here potential energy is higher, here potential energy is lower, hence it is moving in this direction only, and there is no gradient of potential energy. Okay, there is no gradient of potential energy in other direction, W. Okay, there is no gradient of potential energy in other direction. So that is what it is there. So there only 1D flow. Anybody has any confusion over this non-vanishing element? Okay, now we'll move on to step by step. What is our standard method to handle this shell balance approach? What is the first step in that? Standard method to handle this shell balance approach. First step. Here, roll number 30, Money.
Sir.
What need to be done? First step for solving shell balance approach, standard method.
Selecting the coordinate system and origin.
Okay, very good. So select the coordinate system. What do you think coordinate system will be most suitable for given problem? This is all given data just now we have taken out. Now we will implement our standard method and solve the problem. Selecting the coordinate system. What coordinate system you will select? Money. So how many coordinate systems are available?
Cartesian coordinates, sir. Cartesian coordinate system.
How many coordinate systems
Three,
that
sir.
you can use in engineering problem? What are different coordinate system?
Three different types, sir.
Yeah, what are different coordinate systems?
Cartesian, spherical.
Cartesian and polar coordinate.
Polar coordinate. Who is else speaking?
Shubham Ranga, sir. Cartesian and polar coordinate system.
Roll number 1.
91, sir.
91. Okay, Nivas. Nivas. Who is this Nivas? Somebody has joined the meeting with the name Nivas. Anybody knows who is Nivas?
He is one of our class fellows only, but he hasn't joined with that correct name format.
Okay. So, yeah, roll number 91, Shubham.
Yes, sir.
So, one is Cartesian coordinate system. Second one is the polar coordinate
Polar
system.
coordinate system. Yes, sir.
So, in polar coordinate system also there are two polar coordinate system. What are these?
2D and 3D, sir.
No. 2D coordinate system, 3D coordinate system. All coordinate system are 3D coordinate system.
Okay, sir.
There is no 2D coordinate system. So one dimension is not important, then that itself will reduce to 2D coordinate system.
Spherical and cylindrical coordinate system.
Yeah,
sir.
spherical and cylindrical coordinate system. So all the engineering problem is solved using this 3 coordinate system. One is a Cartesian coordinate system where length, width and thickness, okay, x, y, z is considered, and that is rectangular, okay, rectangular. So this is one, and then cylindrical coordinate system. So in Cartesian coordinate system, x varies from 0 to L, y varies from 0 to W, and z varies from 0 to Z. Okay, so this is x, y, z, and then cylindrical coordinate system, r, theta, and z. Okay, r radius, theta angle, okay, angle, and z is a axial direction. This is cylindrical coordinate system, and spherical coordinate system is r, theta, and phi. So this is cylindrical spherical coordinate system. So you can solve any problem by using any coordinate system. Okay, this problem can be solved by using Cartesian coordinate system. This problem can be solved by spherical coordinate system. This problem can be solved by a cylindrical coordinate system. Only the thing is, we will select a coordinate system in such a way that looking at the boundaries, okay, looking at the boundaries, we will select coordinate system such a that it should be easily solved. Okay, it should be easily solved. That is what our main intention is there. So you can, so it doesn't mean that this problem can be easily solved using Cartesian coordinate system. It doesn't mean that you cannot use cylindrical coordinate system. So you can use cylindrical coordinate system. You will get a model equation. Certainly defining the boundary will be very difficult. Solving that problem will be very difficult, and model equation which you will be getting, that will be also complicated. Maybe non-linear model equation you will get if you solve same problem using cylindrical coordinate system or spherical coordinate system. Sometimes your system will be such a that you need to use more than one coordinate system. More than one coordinate system need to be used sometime to solve the problem. Anybody can imagine where you will be needing more than one coordinate system. It is very common example in chemical engineering, which in which you need to use 2 coordinate system. Yeah, anybody has any example where more than one coordinate system will also be applicable to solve the problem? Here our system is this only, so this can be solved using just a Cartesian coordinate system, but sometimes you will be needing more than one coordinate system, and it is very common example in chemical engineering. Yeah, anybody?
Yes, sir. I remember one from physics.
Yeah. Can you name something actually?
Yes, sir.
What?
Motion of a vehicle down an inclined plane, where the motion is in downward direction, which is say x. Its weight is in again downward direction, which is say a z coordinate, and the force of friction against the body.
Okay. In chemical engineering, coordinate system I want to use multiple coordinate system somewhere. That is also one case actually. So now look, we are studying all physics, chemistry, mathematics, and all these basic subjects are studied so that we can apply in chemical engineering. Okay, these subjects are very important, but unfortunately, when you study mathematics, that time you don't know chemical engineering, and when you study chemical engineering, that time you will all forget that mathematics. It is not the thing. You should remember that mathematics, physics, and everything. Now it's time to apply that. So I'm asking about some chemical engineering example you might have been aware of, where if you want to solve that problem, you need to use a multiple coordinate system. Yeah, anybody? So have you heard of cyclone separator? Have you heard of cyclone separator?
Yes, sir.
Okay. So to solve the flow through cyclone separator, you will be needing multiple coordinate system. To solve the flow through cyclone separator, you will be needing multiple coordinate system. Can anybody tell me how? Cyclone separator, if I want to study the flow characteristic inside the cyclone separator, flow characteristic of the fluid or water or air moving in a cyclone separator, so you need to use multiple coordinate system. So can anybody elaborate? Yeah, somebody.
Maybe because of the circular motion and the downward motion.
No, it all depends upon geometry actually. That is what I am telling. So you will select the coordinate system as per the boundaries of a given system. Okay, because this film look like a rectangle. Okay, because this is length, L is the length of the fluid and W is the width of the fluid. Okay, and delta is the thickness. This look like a rectangle. Hence Cartesian coordinate is a most suitable thing. Okay, if some system is having geometry similar to cylinder, so it will have diameter, it will have length, okay, diameter, and complete boundary is there. So that will be categorized into cylindrical coordinate system. If something look like a sphere, then it is a spherical coordinate system. It all depends upon boundaries most of the time. Okay, boundaries of your area of interest. Here I am interested in this film, so I will look for the boundaries of this film. It look rectangular, here Cartesian coordinate system. Now in cyclone separator, yes, somebody else is there. In cylinder pipe, 1D motion. You are asking or you are telling me? 116 Abhinit?
No, sir, just telling.
So you are adding the input or you are just asking me whether we can use?
Sir, you asked that where we can apply, so I have just given one example.
Okay, okay. No, that is not I am asking. I am asking only one system. I need to use two coordinate system. Only one system, multiple coordinate system. So somebody, roll number 111. Vipasvi.
Yes, sir.
Yeah, you are correct. To solve cyclone separator, you need a cylindrical coordinate system and a spherical coordinate system. Can you
Yes.
elaborate on this?
Sir, actually, I answered that when you were asking what are the different types of coordinates.
Okay. So anyway, in cyclone separator, if I want to solve the problem in cyclone separator, I will be needing a multiple coordinate system, that is cylindrical coordinate system and spherical coordinate system. So if you observe the geometry of cyclone separator, upper part is cylinder and lower part is cone. Okay, upper part is cylinder and lower part is cone. So most of the time this cylindrical problem can be solved by cylindrical coordinate system, and conical, if I have conical shape of the boundaries, then it will be easily solved by spherical coordinate system. Okay, so this is the most important point you need to remember. Most of the conical boundaries problem is solved by spherical coordinate system. Okay, so conical boundaries. So then we will have interface. So upper part will be solved by cylindrical coordinate system and lower part will be solved by spherical coordinate system in one geometry itself. means one equipment itself, you will be solving two parts actually. Upper will be cylindrical coordinate, lower will be spherical coordinate system, and I will be dividing that system into two parts. First of all, upper part cylindrical, lower part conical. But our system is not that much complicated. So as we can see, so our film look like a rectangular. So as somebody has correctly pointed out, so this can be solved by using Cartesian coordinate system. Okay, Cartesian coordinate system. So this coordinate system will be Cartesian coordinate system. So once you have selected the coordinate system, what will be second step to solve generalized method to solve this shell balance problem? Second step, what need to be done? Roll number 118. Ashish. Roll number 18, Ashish.
Yes, sir. Hello.
What will be the next step? Coordinate system is selected. Then
Find the direction of velocity, in which direction there is velocity flowing.
no.
As we see the
Before that, you need to fix the origin.
specify the origin and the coordinates.
Okay. Now, because many a times your model equation will depends upon location of origin also. Okay, location
Yes.
of origin also. So, how many possible origins are there for Cartesian coordinate system, Ashish? How many
So,
origin I can select?
as sir, at every edge we can select origin like X, Y, Z.
So, how
we
many
can
edges
like
are there in Cartesian coordinate system?
8 points.
Okay. So now you need to imagine. Okay, you need to imagine the film of length L, W width, and delta thickness. So there
Yes,
are 8 points. There are
Yes,
8
sir.
possible origin in Cartesian
Yes, sir.
coordinate system.
Yes,
And
sir.
you should remember that the model equation which you will be deriving depends upon location of origin also. Same Cartesian coordinate system, same system, you may get a different equation, model equation for velocity profile and flux profile. Hence, it will be always mentioned that a distance is measured from the plate, or distance is measured from the open air, or distance is measured from this point, distance is measured from that point. That is just to give you the hint that where is your origin. Okay, where is
Yes.
your origin? So as such, there are 8 points. Okay, now, so this is, we will fix the origin. So this you can see the far end of the top edge of the fluid actually. You can fix any origin. You can fix
Yes.
any origin. There
Yes,
are
sir.
8 points. So you can fix any origin. So I have fixed the origin. Where I have fixed the origin? At this corner, which is far end of this fluid. So you select any origin. So it doesn't matter. You will be able to solve the problem. But sometime if you select a different origin, you will get a different model equation. That we will see at the end of this problem how it will change actually. So this is my origin. Once origin is selected, select X, Y, Z direction. So which is my X direction, which is my Y direction, which is my Z direction. To elaborate this, so just concentrate on this film. Okay, 3D view of the film. Now from here to here, so this is my film actually. Which film I'm talking about? From this point to this point. Okay, this is my film. You can see my slide. So just concentrate on my this pointer. Okay, this point to this point is one direction. Then this point to this point is my another direction, and third direction is a perpendicular to this plane. Okay, this is my film. Okay, this is my film, liquid film flowing over flat plate. And if I go in 3D view of the film, so this will be my delta, thickness of the film. This will be my length of the film. This is length of the film, and this is the width of the film. Okay, this is the width of the film. So how many origin I can select? I can select origin here. 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 This is fourth origin, fifth origin, sixth origin, 7th origin, and one corner is below this. So these are the 8 probable possible origin for this 3D film. Okay. So for drawing purpose, I am drawing this delta, width and length in appropriate scale. Okay, because otherwise delta is very small as compared to length and W. Okay, this delta is very small. This thickness of the film is very small as compared to width of the plate, as compared to length of the plate. But just for imagining purpose, just for explaining purpose, this is drawn in a scale. Otherwise, this delta is smaller as compared to W and length of the plate. So where is my origin? My origin is top corner. So you can see top corner and far end. Okay, top corner and far end. This is near end and far end. There are two ends at this point. There is one near end and far end. So my origin is at top corner, far end. So where will be my origin? Row number 20, Aviral. Whether this point, 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 or this point. Which
Sir,
point? Whether this point?
Sir, below this, if we take, sir.
This one?
Yes, sir.
Top, I'm saying, I have shown top.
Yes, sir. So top, mein, sir, that's that one only which you selected.
And I'm saying far end.
Yes, sir.
So which is this, that one? Which is that side?
Sir,
this point is my origin actually.
Okay. Okay.
Okay. This is just that is what I am telling you. Don't get confused.
Yes.
Between this film and this film, this is one and same thing. This I have drawn a 3D view of the film, flowing film, just to for your better understanding. So this is my origin. Okay, this is my origin now. Okay, this is my origin. So as I have selected coordinate system, is Cartesian coordinate system, origin is at this point. So this is my x, not this. This is my z. This is my x. This is my y. So what is the boundary for y? Y varies from?
Sir, y will vary from 0 to W.
Very good. Y will vary from 0 to W. Z will vary from?
Sir, 0 to L.
And delta will vary from?
0 to delta. 0 to delta, sir.
0 to delta. Okay. Now you can see there is a flow only in one direction. Okay. There is flow only in this direction, in a z direction.
Yes, yes, yes.
There is a flow in z direction only. So Vx and Vy equals to 0. Everybody got this? Vx means velocity perpendicular to plate. Actually, here is my plate. Okay, this is the liquid film. So there is no velocity in x direction. There is no velocity in y direction. Okay, there is no velocity in y direction because potential energy remains same. This is perpendicular to your screen. Okay, and there is a potential difference of gravitational force is acting only in z direction. So there is only one velocity Vz. This already we have discussed. So this is the only one velocity. So previously the direction was not fixed, which is this direction. Now we are calling it as a z direction. We are calling it as a z direction. So there is a velocity only in z direction. This is clear to everybody. There is no velocity in x direction. There is no velocity in y direction. And still we have not started anything in shell balance approach. Just we are adding, we are getting the information and we have added a coordinate system and fixed the origin. That's all we have done. Otherwise, this information is given, Vx equals to 0, Vy equals to 0. This is given actually, flow over flat plate. There is only one angle given. Okay, angle with a perpendicular gravity, only one angle is given. It means that there is no velocity in y direction, there is no velocity in x direction, there is only one velocity, 1D flow. This is 1D flow. So Vz, whether Vz is a function of x, function of y, function of z. So roll number 35, Pranit. Pranit, roll number 35. Pranit, tell me. VZ.
Hello? Yes,
You
sir.
got the point. You got the point. Vx equals to 0. There is no velocity in x direction. There is no velocity in y direction.
Yes,
There
sir.
is
Yes, sir.
velocity only in z direction.
Yes,
Now,
sir.
z may vary. Change in a velocity Vz in x direction, change in a velocity y direction, change in a velocity z direction. So which variation is dominating? Vx is a function, Vz is a function of x, Vz is a function of y, Vz is a function of z. Vz.
Sir, can you?
Yeah, tell me.
Yes, sir. Like, sir, if we get, sir, in function of x.
It is function of x. Why? So you
Yes,
need to give reason also. Just don't tell me. Okay, and everything is logical. Vz is a function of x. Why?
Sir, like according no slip boundary condition at down there will be no velocity, and with increasing in in x direction there will be increase in velocity, sir.
Excellent, excellent, perfect answer. This is what perfectly point to point answer. Because here at this point I have no slip boundary condition. Velocity is 0. Vz is 0 here. And as I am moving in x direction, slowly, there is a velocity. Some velocity is there. I don't know what is that velocity. But some velocity Vz is there. So which direction I am moving in? So I am moving in x direction. Okay, I am moving in x direction. So here at this point velocity is 0 as I am moving in x direction only. So velocity is increasing. So Vz is a function of x. Okay, Vz is a function of x. Abhinit, roll number 16, 116.
Yes, sir.
So Vz is a function of z.
No, sir. By mistake, sir, I have taken that other coordinate system in my.
Why it is not a function of z?
Sir, because, sir, for fully developed flow, we can assume it to be a constant. The slope.
No, that so Vz is not function of z. This is correct. I am telling. Vz
Yes,
is
sir.
not function
This
of
is
z.
correct, sir. Sir,
But
because
whatever logic you are told, that is altogether wrong. You are telling
sir,
that for fully developed flow, Vz is not function of z.
yes, sir, du by dz will be constant, sir, for fully developed flow. dvz upon dz will be constant for fully developed flow.
So what is the relation of fully developed flow here?
So for fully developed flow, for fully developed flow, the profile will be same along z. So I can say that velocity will
So
not
you are
vary.
telling profile will be same.
Yes, sir. For that profile to be same, the velocity.
Steady state you are telling. Fully developed flow you are not telling actually. So I am telling if velocity here and velocity here is same or different.
So it is constant for fully developed flow plus steady state plus one direction. 1D not a great
No,
assumption.
it is not given 1D flow. We are assuming 1D flow. We are assuming 1D flow.
Okay, sir. Even if we are not assuming it to be a 1D flow, even that it is correct. If
Yeah, you are correct. I'm telling you are correct, but all logic you are giving that is wrong.
So, but how, sir? For fully developed flow, I can say that velocity in z.
Then, according to that logic, Vz is not function of x also for fully developed flow.
No, sir. I am not saying about in the x direction. X direction, it can be.
Yeah, that is also fully developed flow, na? In x direction also you will have fully developed flow. For fully developed flow, why Vz should be a function of x?
Sir,
It's same
profile.
logic what you are applying.
Sir, I
Same
am
logic
applying.
you apply for x direction also. For fully developed flow, steady state. Why Vz is a function of x? Same logic. I'm telling that that logic is altogether wrong. But you are giving me logic, that logic. So according to that logic, Vz is not function of x also. So here actually in this direction flow is there because of gravity. So Vz is because of gravity, and so under the influence of gravity, this is flowing in z direction. Why Vz is not function of z? And this is already discussed in today's class also, in previous class also. Yeah. Roll number 8, Ali, can you explain? Roll number 8.
We are assuming gravitational force, sir, and viscous force, they are so they are balancing their forces.
Yeah. So because
resultant
we are assuming delta is smaller. Okay, delta is smaller, very small. So every molecule is experiencing some viscous forces. Okay, every molecule is experiencing some viscous forces, and they are experiencing gravitational force. So delta is smaller enough to neglect the acceleration. Acceleration of this fluid is not there. We are neglecting the acceleration, but we are not neglecting the flow. So viscous forces are dominating enough to prevent the acceleration, because here velocity is 0, and second molecule it will have some velocity, but it is having some interacting forces. That forces is called as viscous forces. This first molecule is preventing the flow of second molecule first of all, but still it is flowing under the influence of gravity. Okay, under the influence of gravity it is flowing, but that viscous forces are enough to prevent the acceleration. So if this thickness is large enough, so what will happen? Slowly this velocity will increase, and after some time this velocity will be constant. Okay, velocity is constant because thereafter these viscous forces, these gravitational forces will be dominating over viscous forces. Hence there is no gradient of velocity. Okay, if thickness is larger enough, so upper layer will have acceleration. Upper layer of the fluid will have acceleration. Lower layer of the fluid will not have acceleration in that case. Okay, in that case, lower flow will not have acceleration, but upper flow will have acceleration if thickness is very large. So that is the assumption. If delta is small, Vz is not function of z. Okay, Vz is not function of z. Acceleration is negligible because viscous forces are dominating over a gravitational force. This is one. When viscous forces are dominating over gravitational force. Another is continuity equation in case of closed flow. This is not a closed flow, but many a times you will see in future. That time also we will neglect Vz is a function of z. Maybe if we have enclosed boundary are there from all the side in z direction, all the side of z direction. Okay, only one side is opening. So closed flow condition also, that time continuity equation for liquids, it will violate the continuity equation. Hence there will be negligible acceleration in the flow. Okay, this is actually main reason why we are neglecting Vz is a function of z. So Vz is constant in z direction. Everybody got this point? Okay. Whether Vz is a function of y? Yeah, roll number 44, Narendra.
Sir.
Yeah, Vz is a function of y. Vz is varying in y direction.
No, sir.
Why?
Sir, because there's
Because of exit, because of no gravity force.
No, because of no gravity force in y direction, we don't have flow in y direction. We don't have flow in y direction. That is the reason. So appropriate reason should be there. Vz is not function of y. Vz is not varying in y direction. Roll number 62, Ramashri.
Yes, sir.
Yeah. Vz is a function of y.
Sir, I think because it's due to no slip boundary conditions, the whole molecule.
No. Vz is a function of y. No slip boundary condition where it is coming. I am moving in y direction. It can be from here also. It can be from here also. If you are at the bottom, okay, no slip boundary condition. But you are at the top layer, then where is no slip boundary condition is coming? Now here you give the attention. You just look at this molecule at this layer, okay, in this layer, first layer. So which is experiencing air from one side and liquid from another side. So some forces are acting on these molecules on first layer. How about layer here? Actually, if I am moving in x and z direction, okay, at this point, so it will have liquid on the both side in y direction. So certainly this molecule is facing some different forces as compared to molecule at this y and molecule at this y. This y also, one side it is facing air, another side it is facing liquid. Okay, this here both side in y direction it will my molecule will see liquid molecule. Here both side in y direction my molecule will see liquid molecule. But here on one side it will see gas molecule, on another side it will see a liquid molecule. So this is very important trick actually. So whenever you are discussing this, which velocity is zero, which velocity is non-zero, you assume that yourself is a molecule. You assume yourself as a small molecule and assume what you are experiencing there, how you are experiencing there, and then discuss what might be the reason. Okay, what might be the reason? So whether Vz is a function of y. Now can anybody give me input? Roll number 40, Ravi.
Yes, sir.
So Vz is a function of y.
No, sir.
Why?
Sir, because here, if we consider the set of molecules that in a thickness delta, so the by varying by considering a particular thickness of molecules, so a particular thickness of molecules will having same velocity irrespective of the distance from the origin.
Okay, because you are telling delta is smaller.
No, sir. As we are considering, let us say we are considering the upper layer, all of them will have
No, upper layer that was x direction. Upper layer means y and z. That Vz is a function of x. Upper layer. I am telling now this layer. So keep at different value of x, y. Z will vary from 0 to w and x will vary from 0 to delta. So this is the first layer in y direction. So likewise, y varies from 0 to w. At w, this is one layer. So whether it will have same velocity as at y equals to say w by 2 at y equals to 0. That is what we are discussing. This layer we are discussing, this layer of the fluid. So this layer, one layer, like you can slice parallel to this z and x. So x vary from 0 to delta, y vary from z vary from 0 to L. And this slices, different slices, whether it will have same velocity.
Yes, sir. I'm telling that the same thing, sir. When slicing the ZX plane, uh, the different layers of the plane will have different forces acting on them.
Okay, then it will have velocity will vary. VZ will vary.
VZ will that does not depend. I think that does not depend on the distance uh, on y, on the variable y.
No. Actually, VZ will vary in y direction. VZ will vary in y direction. You look at this molecule. Okay, this molecule sitting on this layer. They are facing one side resistance by air molecule, another side resistance by liquid molecule. Now look at the layer at W by 2, where both sides are surrounded by liquid molecule. Here again at y equals to 0, one side is surrounded by air molecule and another side is surrounded by liquid molecule. So forces at this layer will be different at that of W by 2, at that of 0. Okay. So certainly as forces are different, so the velocity will be different in y direction. So whichever that velocity is there. So now here Vz is a function of y. Vz is a function of y, but here we are neglecting. We are taking Vz is not function of y. Just logically, what might be the reason?
Sir, here we are only neglecting it is because of the end effects at only the.
Yeah, very good. So because W is very large. Okay, W is very large. This effect of this open air may penetrate through smaller size, okay, smaller layer. Here also this may penetrate, but W is very large as compared to delta. So this end effect can be neglected. Okay, most of the molecule is surrounded by liquid on both sides in y direction. Most of the molecule, almost 90% of the molecule, the effect of this open surface will penetrate through 5% here, 5% here. So 90% in 90% area in y direction, Vz is constant. 90% area from here to here it is constant. Only it is changing here, it is changing here, and W is very large. Okay, W is very large. So if say I have I'm going from here to Delhi, I'm going here to Delhi, and initially there will be a say I'm going by bike from here to Delhi. So initially there will be increase in velocity. At the end there will be decrease in velocity. In meantime, if my velocity is constant, okay, so increasing the velocity may take 100 meter, decreasing the velocity may take 100 meter, and for 1000 kilometer my velocity is constant. So overall I can consider that my velocity is constant from here to Delhi, because that contribution of increasing velocity and decreasing velocity is negligible. So similarly here also, here there will be a decreasing velocity and here there will be a increasing velocity. Okay, so here Vz, if I am starting from here, this point, so if I am moving in y direction only, so slowly velocity will decrease, because here one side will be experiencing air molecule, and slowly velocity will increase, and then it is constant, then decrease, velocity will decrease, and then constant, then again velocity will increase. But whatever be the increase and decrease velocity, that is in very small area as compared to large W. Okay, that is why we will consider Vz is function of x only. End effects are neglected. Logical answer for this is end effects are neglected. Okay, so Vz is a function of x only. Okay, it is not function of z, because viscous forces are balancing gravitational forces, and it is not a function of y because end effects are neglected. Okay, so Vz is a function of x only. Vz is a function of x only, and this is Vz is not function of z because viscous forces are balancing all the gravitational forces. Okay, viscous forces are balancing gravitational force in such a way that acceleration is negligible. If Vz is function of z, then there will be acceleration. And then if I have closed boundaries, then it will be because of continuity equation. In case of closed boundary, if I have Vz, it will not be function of z in closed boundary because of continuity equation. That will be true for closed boundary condition. It is not function of y because end effects are neglected. Okay, it is not function of y. Then pressure, there will be variation of pressure in x direction only. Okay, there will be variation of pressure in x direction as thickness of the film is changing. Otherwise, there is no pressure is not function of z, pressure is not function of y. As move, so you keep two direction constant. Now z, you select yourself at any point. Now move only in z direction. Move only in z direction, keeping x and y constant. You will see same pressure. Similarly, if you keep x and z constant, move only in y direction. At any point, move only in y direction, you will see same pressure everywhere. But if you move in x direction, so here this is open to atmosphere. If I am moving in x direction, certainly the liquid layer is changing. Layer of the liquid is changing above me. So pressure is a function of x only. So this is what input is there. So this is what actual film is there. This is what 3D view of the film is there. So Vz is a function of x only and pressure is a function of x only. So this is what input from given point. Okay, input from given data actually. So still we have not started anything. Just trying to analyze our problem, trying to analyze the problem and trying to get the input from all the problem. Now we need to take the balance equation, okay, shell balance equation. So now we need to take a shell balance equation. Now we will be selecting a differential shell. How to select the differential shell? I will be selecting the differential length only in a direction of variation. So as there is no variation in y direction, there is no variation in z direction, there is a variation in x direction only. So I will be selecting the differential thickness only in x direction. And z dimension in z will be a 0 to L, dimension in y will be 0 to L, only 0 to W, dimension in z will be 0 to z, only differential thickness will be selected in which direction there will be variation of property. So this will be my differential shell. Y delta x, differential thickness is selected only in a direction in which my properties are changing. My properties are changing only in x direction. So that is the only one direction I need to consider now. Because my property is constant in z direction, my properties are constant in my y direction, my properties are varying only in x direction. So differential thickness need to be selected only in x direction. Okay, because that is only the direction of consent for me, because my properties are changing only in x direction. So if I calculate say in y direction, here I calculate velocity, it is as good as here, because in this y direction velocities are constant. Any one point if I calculate, it is I have calculated for all values of y. Similarly, z direction, if I calculate velocity here, it will be constant throughout. It will be constant throughout. So one calculation is more than enough for z direction and y direction, but my properties are changing in x direction. Hence, I will select the differential thickness in x direction only. So what will be the volume of my differential shell? Volume of a differential shell, roll number 55, Somesh. What will be the volume of my differential shell element?
So the surface area will be L into W and the height.
Height will be?
Delta X.
This will be volume of my differential shell. What is the volume of my liquid film? Total volume of the liquid film, Somesh?
Liquid film. It will be same.
Liquid film. What is the thickness of the liquid film?
Thickness.
Huh?
So what you're asking, thickness or volume?
Yeah, thickness of the film.
The delta.
Delta. So what will be volume of my liquid film?
L into W into delta.
Delta. So why this delta x is selected only in x direction?
So because there is variation in delta.
Why we have not selected delta y and delta z?
So because there is no variation in y and z direction.
Very good. So selecting this differential element is also important. So you should not select all the time delta x, delta y, delta z. Unnecessarily, you will be adding the complication, differential equation in all direction. That will add the mathematical complication. So if my properties are constant in some direction, why to select the differential element? You will take a total boundaries dimensions actually. So I will be taking a differential element only in a direction where properties are varying. Okay, we'll continue in next class. So if you have anything over whatever we have covered till now, so we have not covered anything till now. Just we are trying to understand the problem, and this first problem is very important. First problem is very important. So if you understand this problem properly, you can solve any problem in shell balance. Okay. So say why to select differential element, which direction differential elements is important. Okay, we'll continue in next class.